Okay, so I wanted to review how to read a messenger RNA codon chart. A little bit of background first. So what are we looking for here? So remember that the transfer RNA brings an amino acid to the ribosome as the ribosome reads the messenger RNA. And the ribosome reads the messenger RNA in groups of 3. Each of these 3 base pairs, okay, that we've learned about. So think about this as the backbone, right? This is your sugar phosphate backbone, and these are your base pairs. And remember that in RNA, we don't have thymine, we have uracil. Okay, so the 4 possible base pairs for each of these would be either G, guanine, C, cytosine, U, uracil, or A, adenine. Okay, so this is our messenger RNA, and when it's read by the ribosome will connect it. The transfer RNA brings in an amino acid based on the anticodon. So for each amino acid, it's going to be attached, and it could be just attached to a couple different types of transfer RNA code with the certain anticodons. It could have multiple, and we'll look at that in just a second. But it has something called an anticodon on it, and we don't really need to know a lot about this, but just know that it's going to be the opposite of whatever is on the codon. So for example, if the codon that the ribosome is reading is GCU, it's just going to be the opposite of that, the complementary base pair. So for G, for guanine, we would have cytosine. For cytosine, we would have guanine, and my marker's running out. For uracil, then we would have adenine. So this is going to be CGA. But that's not what this is about. This is our messenger RNA codon. So this is this, and it tells us what amino acid is added to the protein chain when the ribosome reads this. So let's look and figure out what amino acid should be added for GCU. All right, so the amino acid that would be added for GCU, first of all, we start on the left-hand side, and we find G. All right, then we go to U, so we go across and we find U. All right, so let's come down to where they meet. So G and U. All right, now the last, I'm sorry, I did that wrong. It was GCU. My apologies. G and C. All right, so then GC and then U. So alanine. So the amino acid that we've got here is alanine. Okay, and you can see from our chart that alanine could be attached to a transfer RNA that will attach to GCU, but it also is attached to transfer RNAs that will attach to the codon GCC or GCA or GCG. So all of these amino acids that we're looking at have, well, let's see, not all. I think tryptophan maybe just has one, but most of these have multiple transfer RNAs that they are attached to. And so I hope that helps you. Let's do one more, especially since I messed that one up. So let's pretend instead, put in some different letters in here. Let's pretend we're doing let's see, I don't want to grab a stop one. UGC. Let's do UGC. All right, so if this is UGC, the opposite for the anticodon would be A, C, G. But again, we're not going to use that for our chart. It's just good to know, to understand what an anticodon, how it reads. Okay, so if it's got this anticodon, what kind of amino acid would this transfer RNA brings to pair with UGC? So let's find U, and then G, and then amongst these we're looking for UGC. So it's cysteine. So this would be cysteine. Okay. All right, so I hope that helps. If you have any more questions, let me know.